Bismillahirrahmanirrahim. Welcome to the Electrical Engineering channel. In this lecture, I am going to show you the torque speed characteristics and its connection with the type of the synchro induction motor, which is called slip ring type or wound rotor type induction motor. So torque speed characteristics, which we also discussed in the previous lecture, are also plotted over here. And from the previous discussion, we are sure that whenever the slip is zero, the torque produced in the induction motor is equal to zero because there is no relative motion between the magnetic field and the rotor. Similarly, when the slip is equal to 1 at this time, the mechanical speed of the rotor Nr will be equal to 0. So in that case, the slip will be equal to 1. And this condition satisfies or this condition is analogous to the starting torque. So at this condition where the slip is 1 or the rotor speed is 0, this is the starting condition. And all these points which we can see over here are corresponding to the starting torque for different values of rotor resistances. So when we have the minimum value of rotor resistance Ra, the starting torque will be minimum. Similarly, as we increase the rotor resistance, the starting torque starts increasing and it will be maximum at Td for the value of rotor resistance equal to Rd. And Rd is the maximum among all these resistance values. Similarly, Td is also maximum among all these torque values. So it means when we want to get high starting torque, then we must have a higher value of the rotor resistance. So keeping this idea in mind, we have another type of induction motor whose rotor is phase wound type. Okay, so the stator of induction motor is identical. Only the types of induction motors features different varieties of the rotor types. So first type is a squirrel cage type induction motor. That type of induction motor is basically a trivial or a low cost induction motor which doesn't provide sophisticated characteristics and better control over speed and the torque. More sophisticated type of induction motor has a phase wound rotor whose schematic diagram is shown over here. So this is the three-phase stator windings which are connected in star or Y configuration, and this is the rotor which is also connected in star connection. Okay, so in this wound rotor type induction motor, we have three-phase windings of the rotor, and the terminals of all these three phases are connected to independent slip rings, and these slip rings are then connected to the variable resistors, and these variable resistors are also connected in a star configuration. So the purpose of providing these variable resistors is to vary the rotor resistance externally. So when a motor is running, we have the option to vary the rotor resistance by varying the knobs of these rheostats. And these slip rings are basically used to provide a contact between rotating rotor and the stationary rheostats. So this is a very promising feature of this type of induction motor. And whenever motor is stationary, we will increase this series resistance for all the three phases to get higher values of the rotor resistance, and that highest value of rotor resistance will give highest starting torque. But from these characteristics, we can see that higher value of rotor resistance is good for achieving high starting torque, but the running torque will be small for higher values of rotor resistance. So here we have starting torque, which is the highest over here. But when the motor is in a running condition, its operating point will be somewhere over here. And at this point, we will have low running torque. So at start, we want to keep the rotor resistance at highest values to get high starting torque. And when the motor starts shifting towards the running mode, the value of this rotor resistance should be decreased to get a highest value of the running torque. So this is done over here, and these variable resistors are positioned at maximum values at start, and at the running condition these values of resistances are decreased to get highest values of the running torque. So this discussion of induction motor starting and running is very much analogous to the running of a car or a motorcycle. So whenever a car, we want to start a car from the stationary condition, we use the first gear. Okay, the first gear provides a high starting torque, but we cannot use this first gear to run our vehicle at 80 kilometers per hour. So at 80 kilometers per hour, we need a high running torque. So for that purpose, at start we put on the first gear to get high starting torque, which helps the vehicle uh, mm, to run from the stationary condition initially. Then we start increasing the gears from two to three, three to four. So by increasing the gear number, we are actually reducing the starting torque, and we are actually increasing the running torque. So the same idea applies over here, and at start we need to fix the value of the rotor resistance at highest value, and as the motor starts move shifting towards the running condition, these values of rotor resistances should be decreased, and vice versa. So when a motor is coming back from running mode to the stationary mode, these values of resistances should be decreased. So that's all about our today's lecture. I hope you have enjoyed and understood the concept which is explained in this lecture. For watching more similar videos, please stay tuned to this YouTube channel. Until the next lecture, it's goodbye.